Have you ever wondered how genealogists can trace back the genetic history of a population? They use theoretical genealogies. Theoretical genealogies are used to make simulations that test assumptions about the history of a population using observed data. But how do they get this data? The answer is with the coalescent theory. The coalescent theory is a model of population genetics where we look back in time to follow the variations of a genetic trait passed from one generation to the next back to its most recent common ancestor. The coalescent theory is also a way of showing our assumptions about the shape of an allele tree. As you can see, there are two examples of allele trees shown. An allele is a variation of a gene. So in allele trees, we look back for the approximate times that these variants in genes occurred. We can use a mathematical formula to predict where these gene variations may have occurred. Let's get some insight on the fundamentals of the coalescent theory. We basically start off with a population as shown here. Then we sample the population to determine the relationship of alleles amongst the individuals of this population. So as you can see, I just sampled the individuals. So what we can do next is predict when these alleles coalesce or come together until we find the most recent common ancestor that has the coalesced version of the alleles. So this is how we basically predict how they coalesce until we get the most recent common ancestor. But what we still have to determine is how these variations occur. These variations. So we can learn more about this by analyzing the mathematical formula that theoretical genealogists use. We questioned earlier, how can we predict gene variations? We can do it with this equation. This equation allows us to find the probability of coalescence using other factors such as the probability of non-coalescence and potential parents. See, you don't have to be a mathematical wizard to understand this.